All right, guys, next topic here is on NPVs and still proving identities, but we're going to prove them by actually using physical values for x and theta, okay, and actually using the angles, which is basically old stuff that we did, but now kind of using them in an identity sense. So I'm starting here with NPVs from grade 11. So just a reminder that NPVs are values that cause a fraction to have a denominator equal to 0, which basically is just telling us that we are not allowed to divide by 0 in the question, okay? So we are not allowed to divide by 0 in any question we have. This looks a little bit more like grade 11 for you guys, so in this case, x could not equal 0. In this question, x plus 1 could not equal 0. So you just kind of take it out of the fraction, solve for when it's equal to 0, which in this case, x would not be allowed to equal -1. Again, just because in math, we're not allowed to divide by 0. Okay, so let's look at it in terms of trigonometry. So I'm going to use the bottom of your guys' sheet there, and let's take a look at example 1a first. So for example 1a, we have tan squared x plus 3 is equal to 1 plus 2 cos squared x over cos squared x. Before we start doing the rest of the question, we're going to change any sort of tan, cotan, secant, or cosecant part into their reciprocal or their fraction. So the only thing I'm going to change here is I'm going to change tan into sine squared over cos squared x. And I'm actually just going to ignore the rest of the question because 3 can't change, cosine's fine on its own, and cosine's fine on its own there. What I need to do now is I need to pick out any denominator situation. So that would mean cos squared x here, because tan is the same as sine over cos. So I'm dividing by cosine there, no division there, and then there's a division by cos squared x here. So the only thing I care about is cos squared x not being equal to 0. So there's no other division happening. I can basically ignore the rest of that question. The question is, what is x equal to in order for cosine to be 0? Well, there's a square root on the left side here, so using this as my equal sign, I'm just going to square root both sides, which is not a big deal because in this case, square root of 0 is just 0. What is x equal to when cosine equals 0? Well, this is where we find the angle for x given the exact value equal to 0. When is cosine equal to 0? Well, think about your unit circle if you need to, right? Cosine's equal to 0 on top and bottom. So x in this case would equal pi over 2 and 3 pi over 2, but more specifically, it means x can equal anything except for pi over 2 and 3 pi over 2, because if that was plugged into either one of these situations, I would get an undefined value for my question. I am not allowed to divide by 0. I can stop there because if you look at the top of your question, it says it wants the interval between 0 and 2 pi. If it was anything bigger than that, we could add some coterminal angles if we needed to. So basically NPVs are solving angles, which we've been doing before anyway. It's just recognizing that NPVs only care about denominators. So let's finish off NPVs with question B. Obviously the only denominator is this guy here. There's no secants or cosecants or anything. So I go cos x plus 1 cannot equal 0. I'm going to move the positive 1 over to the right. So I'm trying to make this entire expression equal to 0, which means we just move the 1 over. So when can cosine not equal -1? Well, let's use this unit circle again. Cosine cannot equal -1 on the left side at pi or 180. So x in this case cannot equal pi. If you got some super fancy formula, just look at all your denominators. If you have tan, cotan, secant, or cosecant, change them into 1 over sine, 1 over cosine, etc. Pick out all your denominators and solve for 0 in every single case. So that is the review of NPVs. The rest of the booklet looks a lot more like the identity stuff we did in booklet 1. The big change is now instead of just doing it algebraically with no value, we're going to substitute in a value for cosine. So in this case, instead of changing secant, tan, and cotan, which you could do, but it would be extra steps that you don't really need, I'm going to take x equal to 60 degrees, and I'm going to plug into the left-hand side, and eventually I'm also going to plug into the right-hand side. Okay, so the left-hand side is secant at 60, all over, tan at 60, plus cotan at 60. On the right-hand side, it only wants sine at 60 degrees. Well, where do all those values come from? All of those values come from the good old table. This is just our tan graph, but that's just the table that you guys are used to seeing. Okay, it's only in radians there, but we can think about those in terms of degrees. So 30 degrees, 45 degrees, 60 degrees, etc. So using the table, I'm going to substitute in for secant. Remember that cos at 60 degrees is equal to 1/2. So that means that secant at 60 is 2. It's positive 2 because we're at 60 degrees, which is in quadrant 1. Tan at 60 degrees is equal to root 3. Cotan at 60 degrees would then be equal to 1 over root 3. So I'm just going to deal with the left-hand side for now. Because we have two fractions on the bottom, it's probably beneficial to get a common denominator, just like the identity questions in the last booklet. So this is root 3, this is 1, so I'm just going to multiply by root 3 on top and bottom in order to get the exact same denominator on left and right. So that equals 2 over. The denominator in this case is going to be root 3. Root 3 times root 3 is 3 plus the 1 on the right. That is going to equal 2 over 4 over root 3. We're dividing a fraction, so we're going to go 2 times root 3 over 4. Since that is over 1, we're going to cross cancel. This is going to be 1, this is going to be 2. 1 over 1 times root 3 over 2 is just equal to root 3 over 2. So that's the left-hand side by plugging in 60 degrees. The question is, does that equal the right-hand side? Sine at 60 degrees from the table is root 3 over 2. So I'm just going to zoom out my camera a bunch there. Hopefully we can see it's a little bit blurry. Let's see if we can focus that. So root 3 over 2 on the left, root 3 over 2 on the right. Left-hand side equals right-hand side. And we have proven it physically with exact values. Whereas the last booklet, we would have done that algebraically. Double I, I'm going to quickly write out here, is the exact same thing, except this time x is 3 pi over 4. So if I had to do the left-hand side, we're going to basically redo the question. So on the left-hand side, we would end up with secant at 3 pi over 4 over tan at 3 pi over 4 plus cotan at 3 pi over 4. So from our exact value table, pi over 4 for cosine is equal to root 2 over 2. And we're in quadrant 2. So the top part of the numerator is negative 2 over root 2. On the bottom, tan at pi over 4 is 1, but in quadrant 2, it's negative 1. So again, very important that we know we're in quadrant 2 in this question. And then cotan is 1 over negative 1, which is just negative 1. So I have negative 2 over root 2, all divided by negative 1 plus negative 1, which is negative 2. So that is equal to negative 2 over root 2 times negative 1 over 2, right? Flip and switch. Doesn't matter where the sign goes. The negatives cancel. The 2's cancel. And I get 1 over root 2. Right-hand side, sine at 3 pi over 4 is equal to root 2 over 2, and it's positive because we're in quadrant 2. You might say that left side doesn't equal right side, but we haven't done a lot of rationalizing this year. If root 2 is on the bottom, just multiply root 2 over root 2, and now the left-hand side equals the right-hand side. This whole page, this whole question is basically proof that when we do the last booklet for all x values, so we didn't plug in any x values at all, we just proved left-hand side equal right-hand side, we tried 2 random angles. We did 60 degrees and we did 3 pi over 4. It wouldn't matter what angle you plug in. If you plugged in 120 degrees, guaranteed left side would equal right side. And that's kind of the whole point of this booklet. Whether you do it with angles or you do it algebraically, proving will always be correct from left-hand side to right-hand side.